So, in this lesson, we are going to set placeholders to help us design the world a little bit faster by randomly instantiating the elements that compose that world. We will also add some details in the objects already in the scenes, construct the structure of game scenes, and export to publish the game in an online store. Let's start by downloading the new assets and replacing them in our project folder. Inside the nature elements sprite, you have these three new images. These will be the placeholders for rocks, trees, and grass. Set them to placeholder rock, placeholder tree, and placeholder grass, with a pivot in the center location of the plane that should touch the ground. You don't need to be very precise, but accuracy will facilitate the work later. Now, in the hierarchy, select all natural and items objects and delete them. We should organize a little. Create an empty object called world with trees, rocks, grass, and items inside. Also, drag the grid inside the world, and this world object is actually your map. Now let's drag the tree placeholder to the trees object in the hierarchy. It should be at 0, but if it's not, just reset the transform. Also set the sort point to pivot. This will be the object that we planned to have a tree in that location. When the game runs, this will be replaced by one of the trees we have. If you only have one, your forest will look boring. But if you have many, they will be more organic because each placeholder will be replaced by one random tree. So create a script called AutoPrefabSpawner and add it to the placeholder. We don't need the update because this will run only once before being removed in the beginning of the game. We just need to do three things in this script. Have an array with all objects, choose and instantiate a randomly choose object from the array, and destroy the placeholder. So, this array will be fed to the instantiation command. A random selection will choose the index in the array, and once done, we remove the placeholder from the world. In Unity, we should set the prefabs field with the objects we want this placeholder to plant. And that's it. If we run, the placeholder should transform itself into another object. If we play again, it will probably select another one. So, drag the placeholder to the prefabs folder to make it a prefab. The question is, why do we need this? Well, now we don't need to worry about being random when designing the map. We can just duplicate the object and drag it to a new location. When we play, we should have a more organic forest. The same concept could be applied to the rocks. Drag the rock placeholder to the hierarchy, add the script and fill the prefab fields. Make it a prefab and duplicate as you need rocks. To do the same for the grass, we need to make the grass prefabs first. Select all the grass sprites and holding the Alt key, drag them to the grass object. If you don't hold the Alt key, Unity will assume you are trying to make an animation with different frames. That's not the case. You want individual objects. Once done, select all grass objects, set the sorting point to pivot and drag all objects to the prefab folder. You can delete them from the hierarchy. Now that we have all the grass prefabs, we create the placeholder in the same fashion as the trees and rocks. Last placeholder is the items placeholder. This will be a little bit different because we cannot destroy the spawning point and also prevent spawning if the previous item is still there. Set up the placeholder from the new image in the item element's main sprite. Create a new script called AutoItemRespawner and add it to the item placeholder object. Inside we can do the same as the others, just copy-paste the entire code. First, we can delete the destroy command. This spawner will be in the scene all the time, but we need to disable the placeholder sprite. So, in the beginning of the start method, we disable the sprite renderer. Then we need to set a timer to respawn another item. To make it a little unpredictable, let's randomize the waiting time between two numbers. This script is dangerous because it calls itself automatically. If we allow that call every frame, the computer may crash, so these variables should have default values above 0. We will also need to check if there is an item in the place already, so we will need a boolean to work that information. In the start method, after disabling the placeholder's sprite renderer, we can instantiate one item. This is the beginning and there is no item yet, so no need to check that. After the instantiation, we call the coroutine responsible for waiting, checking the availability of the spot, instantiating a new item, if possible, and call itself to repeat the process. This coroutine does not exist yet, so let's create it. A coroutine is a method that can spread its action along many frames and can process operations that are asynchronous, like waiting a certain amount of time. In our case, we need to wait at least 50 seconds to instantiate another item, and a coroutine can be stopped until the time runs out and then continue with the instantiation command. In the description you have a direct link to the Unity's coroutine manual. So, we tell the coroutine to wait. In this case it's 0 because it's the first time, but we will add a +1 just to be sure that this method does not happen to loop every frame. Then we check if the spot has no item already, and if not, we instantiate a new one. At the end we call the coroutine again, but now with a bigger waiting time. And every time this runs, it calls itself and stays locked in this behavior. Now we just need to check if the item was removed and change the boolean accordingly. So, every time we pick an item, it will exit the placeholder collider and this function will run, putting the free space as true. And this being true, the instantiation runs normally. As soon as the instantiation happens, the item collides with the placeholder and it goes not free again. For this to work, the placeholder needs to have a rigid body 2D locked in position and a box collider 2D as trigger. We can make it quite big to prevent an item from appearing right next to another in case the player puts another item too close. To avoid colliding with the ground or another object, we will set up some collision layers. In Unity, create two new layers: Item and Item Placeholder. In Preferences, Physics 2D, Layer Collision Matrix, clear the step sounds from these new ones, and allow the Item Placeholder to collide only with items. Now we set all items to the layer item and the placeholder to the layer item placeholder. Make sure the placeholder prefab is set to have the items and just to test with a very low number in the minimum and maximum waiting time. If we run the game, we can see that items is there, but no other appears in the same location until we pick it up. But we have a problem. The placeholders are interfering with the raycast. We will need to also set hit layers for the raycast. In the interactions script, Before the raycast, we set the layer mask for the raycast to ignore the item placeholder layer. In the raycast command, we need to add the layer mask value that should be in the 4th position after the raycast distance. Because we also don't have that, we add 1000f, layer mask. At this point, we have the necessary tools to design the map as we want. We can have a big terrain and hundreds of trees, rocks, grass and items. But after having a big world, if we play the game, it looks slow and not very responsive. Why? If we click on this Stats button on the top right of the game window, we can see that we have a very low frame count per second. This number is really low, so something is wrong. We need the profiler in the Window Analysis menu. We can see that this big blue area is taking the majority of the frame time. If we click on it and go down here to analyze one frame in detail, we can see that this blue thing is the sprite skin script. This is happening because of the animation on the trees. Let's manually disable the trees to see if we get more performance. Well, here is the proof. We need to disable the trees we are not rendering in order to not process them. To prevent unnecessary processing, let's add a trigger collider to the camera, and every time something exits the collider, it will be disabled. The opposite will also happen. We need 2 scripts, one in the camera, more generic, to collide with the object to occlude, and another, more specific to the object, that receives the command to be active or not. Create a script called DisableOffCamera. Select all 4 trees in the prefab folder and drag the script to the inspector. Edit the script and add the following logic. An access to the Unity's 2D animation to allow us to work with the sprite skin component, a public variable to set the state from the camera script, a method to operate the occlusion, a command to get the components and enable or disable them, and a command in the awake method to run once the code when the object is put in the world. Now in the camera object we add a rigid body 2D, set to 0 gravity and lock in rotation. Add a box collider 2D, set it to its trigger and bigger than the camera, especially in the bottom part, once the trees are tall and the colliders is only on the roots. This collider will interfere with the raycast, so a camera layer will be needed on the camera. In the interactions script, add the camera layer to the raycast layer mask exceptions. You need to use the OR operator. It is that vertical bar on the left of the number 1 key. Now we need a script to command all trees to enable. Create a script called Occluder and put it on the camera. First we detect a collision and check if the other object has a DisableOffCamera script. If it has, it's because it needs to be enabled or disabled, so we set the state to true and run the update state of the other object. This should enable the object. When the object leaves the camera area, we do the opposite. Save and return to Unity. If we play, we immediately feel the game very responsive and fluid. Let's look at the scene panel while playing. As you can see, the trees are being disabled when out of the camera and enabled when they should appear. When I walk down, I see some trees appearing. This is because the collider is not long enough on the bottom part. So let's fix that. This has nothing to do with game design. This is optimization, and optimization is a very important thing, especially in big games. In the interactions script, we need to make sure we have all interactions in the switch case. We can use the simple full interaction on all items, but to demonstrate how we can do different reactions with the same code, we are going to set all mechanical calculations as a percentage instead of absolute, like in the energy case. So, for iron, copper, gold and glass, we multiply the value we have in the health with the one we are interacting with. In Unity, set all metal items and glass to increase the mechanical based on the material's weight. So iron goes 30%, gold and copper goes 20%, and glass goes 10%. Similarly, the Robo to process those materials need to spend some energy, so iron minus 0.2, gold and copper minus 0.1, and glass minus 0.05. Lithium can have some residual energy, so increase the energy by 0.02. This should make the game more dynamic and demanding. To make the Robo die, we will need an animation. We select the Robo front and create a new animation called Die. Let's keep the animation simple, just falling is okay. We do the same for the back. And in the animators, we add a new trigger called Die and set up the transition. Done. Now in the Robo script, where we already set the animations, we test the energy level, and if it's greater than 0, everything runs as normal. But if it's not, we set the next animation to die. To prevent the movement to be applied after dying, we also need to put this if energy greater than 0 statement here, and the movement will no longer be applied if dead. If you don't do it, you are able to move the character even if it's dead. We need to make sure the dying animation does not have the loop option enabled. Let's multiply the speed by the mechanical to make the Robo walk slower if the mechanical are not okay. I will make the mechanical degrade faster just to test. We need to prevent the numbers to go negative. We can do that in the Robo health script. If it goes below 0, we force it to stay at 0. And the others are the same. Seems fine, let's just put some realistic numbers in the Robo and overwrite the prefab. Now that the game mechanics are done, let's build the menu structure. Let's create a new scene called Intro in the Scenes folder. Inside, we add a canvas and set it to the camera as usual. At this point, we can do a Save As and call it Main Menu. We should have 3 scenes. Let's change the name of the sample scene to Game Level and drag them to the build settings, keeping the intro on top. In the intro scene, we just need 3 things: a background image, the creator brand logo, and the music. We can stretch the image to the edge of the canvas. This is just paper texture, so if it is a little bit stretched, no one will notice. We have another image for the logo. This one will be set to a reasonable size, maybe 500. The music just needs to be dragged to the hierarchy. We set the play on awake and the loop on, and the volume to 0.15. We create a script called AutoSceneLoader and add it to a new empty game object renamed to Other Scripts. To load scenes, we need the Scene Management library. We also need the name of the scene we are going to load, the wait time, and the name of the button to skip the autoloader. We start by calling the coroutine that waits and loads the scene. In the update, we look for the button, and if it's pressed, we load the scene immediately. Because this will unload this scene, the coroutine stops automatically, so we don't have a double triggering. In the Unity, we set the name to Main Menu and 3 seconds of waiting time. If we play, the main menu scene will load automatically after 3 seconds. The cancel button is the escape key in the keyboard. Everything works fine, so let's build the main menu. We can copy the canvas from the intro. We just need to set the renderer camera again. Let's change this logo to Main Menu and set the correct image. In the item elements, we have these new sprites, the panel and the button. We set the image to 980 by 980 and preserve aspect. Inside we have a button and set it to use the button image and the font to Orbitron Medium. We then duplicate the button and bring it down to be the Quit button. Also, we need 2 text boxes for the title and info. At last, we drag the Robo front, add a skin sprite, roughly mount it and add the idle animation. Done. We just need to create the scripts for the buttons. we create a script called ButtonQuit and drag it to the Quit button. Inside, we just need a public method the button can access to quit the application. Done. But we can only test it in the build, not here in the editor, so we test it later. In the inspector, we drag the script to the button's onClick and call the method. Create a script called ButtonChangeScene and drag it to the play button. In this, we need a reference to the scene management and then a public method to load the scene. This method is expecting a string with the name of the scene. This variable will be set in the button itself. In the button's inspector, we need to write the name of the scene we want to load, and that's it. If we play and click on the play button, we should go to the game. We are playing and eventually will die, so we need to detect the game over. Let's create a new script called GameOverDetection. In the game scene, we create an empty object called OtherScripts and drag this script there. The Game Over screen will not be a new scene, it's going to be a panel on top of the game. This script will be responsible for enabling the Game Over panel after some seconds the Robo is dead. For this, we need three references: the health to check the energy level, the panel object to enable it, and the waiting time. We also need a working variable to the dead state to avoid multiple triggers of the coroutine. In the beginning, we set the characters alive and disable the Game Over panel. During the game, we check the energy and if the Robo is alive. When the energy goes 0, we start the coroutine that waits to enable the panel, and we set the boolean to true to avoid retriggering the coroutine. The coroutine itself just waits some time and activates the panel. Now in Unity, we select the canvas and add a new image. We set up the image with the panel sprite, and inside we add 4 text boxes to hold the game over title, the score of the game, and the best score ever. At the bottom, just a small info box about skipping this panel. To make the panel load the main menu automatically, we can use the same AutoSceneLoader as before. We put that script in the panel and set the values to main menu and 5 seconds. Because the panel is disabled as start, this script will not run, but when we die, the panel opens and the script starts to count the time to change the scene. To test, set the fields in the Game Over detection and go to the Robo and set the energy decay to 50. So we should experience 3 seconds of delay after we die and another 5 to go to the main menu. If we click on the escape key, we should go immediately to the main menu. This being functional, we just need to set the wait time to a little bit longer and add the script to write the score in the panel. To save scores and high scores, we are going to use the integrated PlayerPrefs system. It's not the best solution to save the game, but because this is a beginner's lesson, we have only 2 numbers to save, and it's just for you to experience the logic behind saving data. I'm okay with it. Eventually, if the game goes bigger, we can talk about a decent save system. In the Robo health script, we had two variables to hold the starting time and the state boolean to the counter. The score will be the time we stay alive. At start, we set the canCount to true and the start time value to the current time. At this point, we don't need to do anything else. The game will run and we'll just wait for the player to die. Once we die, we set the counting to false and compare the current time with the time stored at the beginning. We subtract one to another to get the difference and have a score. At the same time, we store that value in the PlayerPrefs variable called score. Then we compare the score with the previous best score, and if there is none, it will be 0. And if the score is higher, we replace the best score with the score. At the end, we save the PlayerPrefs values and it's done. To update the text in the Game Over panel, we will need a little script that can be used in every text that comes from a PlayerPrefs float variable. We create a new script called WriteFloatFromPPrefs and add it to every text box we need to write text on. Inside, we need a reference to the TMPro library and 3 fields: the name of the PlayerPref variable, the setting of the decimal places we want to write, and a string to hold a prefix to the number. In the start, we get the text box and add a prefix with the float number separated by a new line character. In Unity, we just need to set the fields accordingly to have the text updated based on the PlayerPrefs value. If we run, we should have the numbers there. Nice, but when we get to the main menu, we are missing the information there. Well, it is the same thing. In the main menu scene, we just add the script to the report text and set the values. Remember the music in the intro? Well, that needs to keep playing during the game. We create a new script called DoNotDestroy and add it to the music game object in the intro scene. This one is super simple. We just set the object to the DoNotDestroy in the start. When we play, the music will jump to the DoNotDestroy game object and will not be removed when you load the main menu. In the Player tab of the project settings, set the company name to your own branding and drag the icon sprite to the icon field. In the build settings, make sure you have all scenes in the list and the first one is the intro. Then click the Build button. Create a new folder outside of the Assets folder called Builds. Then another with the type of system, PC or Mac, and select the folder. Unity will build the game to a standalone executable file that you can distribute. This now is your game. This is the end of this series. If you follow all the lessons, you should have a wide idea of what this game dev thing is. Many tutorials online with very interesting solutions and really good information are short at one point. The context is always imaginary. Here I tried to make the context real. We built a game, and when we learn how to use a trigger or a camera or any other thing, you know exactly where it goes and why. On the other hand, this game is a very basic and not a good solution for a big scalable game. Other techniques are necessary, but I didn't work with them because of the beginner's scope of this series. I really enjoy this process and I'm quite proud of the result, so I'm planning to continue these video lessons, maybe to evolve this game or maybe to create another one. Well, time will tell. So I hope you learn at least one thing. To make a game, you need to build the systems, step by step, until you get all the behaviors. And sometimes it is very difficult to know what to do. The best solution is always to test, and if it doesn't work, you should delete and restart with another approach. I will do just a simple extra short video on how to publish this game in the itch.io online store. So, I'm hoping to have you there. See you!